Okay, so this is week 12, video number 2. We are finishing off organic chemistry today. We have talked a lot about organic chemistry in the last 2 weeks, and it's a lot of information. So after this second video, I think that's enough, and we will just start to review for our upcoming exam. Last video was carboxylic acids and esters, and this video is the end of chapter 14. This is going to cover amides and amines. So amides, there are 3 different types of amides. And we have an unsubstituted amide when it's just a C double bond O with an NH2. We have a monosubstituted amide when instead of an NH2 off of the carbonyl carbon, the C double bond O, we have an R prime group, which can be the same thing as R. These guys can all be the same, or they can all be different. And then we have a disubstituted amide on the far right. Notice the abbreviations, how the abbreviations all look similar. They're all similar in that they're CON. CON means it's some sort of amide. Okay. Now, before I even give you the rules on how to name, I just want to practice naming amides because it's very similar to the corresponding carboxylic acids. If you remember, I said that an amide is a derivative of a carboxylic acid. So instead of ethanoic acid, this is ethanamide. Instead of ethanamide, this one in B, we have a methyl group off of the nitrogen. So we call it N-methyl ethanamide. In C, we have 2 methyl groups dangling off of the nitrogen. This one's disubstituted. So it's N-N dimethyl ethanamine. So what are those big N's? Those big N's just mean that whatever I'm talking about next, like methyl or ethyl, is attached to that nitrogen. Okay, so we'll break that down now with some actual rules, and then we'll practice them again. You'll be happy to know that video number 2, there's no reactions. This is all naming amides, naming amines, and also drawing structures of amides and drawing structures of amines. So for naming amides, it says here, amides with an unsubstituted NH2 group are named by replacing the oic acid with amide suffix. We did that on the very first example, A, on the last page. So as an example, CH3CH2COH. That's propanoic acid, right? 3 carbons. Does have a common name, propionic acid. Now these might not all be amides that I draw. I'm going to stick one of them in there that's not. But this is 3 carbons. It's not propanoic acid. It's propanamide. Okay, next one, CH3CH2, C double bond O, NH. This one has an ethyl group off of the nitrogen. It's off of the nitrogen. That ethyl group is not a branch off a carbon. It's a branch off an N. N-ethyl propanamide. Now look at this next one, CH3CH2, C double bond O with an O. Wait a second, we learned that last video. That's an ester, methyl propanoate. Okay, careful, that's an ester. I threw that one in. All right, the last one over here, CH3CH2, C double bond O, and the nitrogen has got 2 different things attached to it. So ABC order, we have N-ethyl, N-methyl propanamide. Okay, pay very close attention to the ABC order there, right? E-M. I can't call this N-N diethyl or dimethyl because they're different. All right, practice makes perfect. There are homework problems in chapter 14 on that stuff. Example, name the following amides. All right, so more practice here. CH3CH with a branch CH3 down, CH2CH2COOH. Actually, it's just name the following, my mistake. But that's a carboxylic acid, right? You recognize the COOH, far right, carboxylic acid. So 1, 2, 3, 4, the branch is 4-methyl pentanoic acid. All right, B, I've got a benzene ring. Sometimes I draw a circle. Sometimes I draw alternating double single bonds. But this is N-methyl, P for para, N-methyl para-chlorobenzamide. Where do I get the benzamide from? Well, it's benzoic acid, but it's an amide, so it's benzamide. I do have an N-methyl, and it's a chloro all the way at the 1,4 position. So if you want, you could also call it N-methyl 4-chlorobenzamide. Okay, so that's a tough one. It doesn't get much harder than that one right there for the whole organic chemistry. Next example, Now I'm going to give you the names. I want you to draw structures. Some people find this to be a little bit easier. A, 4-methyl-pentanamide, and B, N-methyl-butanamide. Well, 4-methyl, you see the number 4? The 4 tells me that the carbon is off of carbon 4. Now, if you look at B, the N tells me the methyl is off of the N. That's how the N is different than the 4 for A and B. So if I draw this all out with my skeletal structure and then bring it back into a condensed version, I get the box on the bottom left. N-methyl in B, I got to put my methyl off of the nitrogen, guys. Okay, not off of any of the carbons. So then I draw out my skeleton scratches and I put it together into a nice structure. I'll never box up any structures that aren't complete, and neither should you. Okay, those little sticks that I was drawing, those little dash, 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 just me helping me to draw the final structure. All right, so that's it for amides. Now amines. Notice it's spelled different. Amines. Okay, these do not have a carbonyl carbon involved. These are unlike the carboxylic acids and the esters and the amides. These are simpler. This is just an ethyl group or a methyl group or some sort of organic group with a little NH2 attached. So amines contain one or more organic groups bound to nitrogen, different than amides. Okay, R, NH2, primary amine. R2NH, secondary amine. R3N, tertiary amines. See how the nitrogen has a lone pair? Our nitrogens will always have a lone pair in organic chemistry. They're rarely drawn, but it's understood there's always a lone pair there. Okay? And the R groups can be alkyl or aromatic. They're quite often alkyl groups. So like a CH3 or a CH3CH2. Each nitrogen has a lone pair of electrons, though they're not always drawn. They have a tendency not to be drawn. So primary amine is a nitrogen that's attached to one carbon. Secondary amine, nitrogen is attached to 2 carbons. Tertiary amine, nitrogen attached to 3 carbons. Sometimes you can have 4 carbons attached, which is what I'm talking about here in the notes. A 4th organic group. You will not see this very often. I just wanted to put it in there. It's called a Quaternary Ammonium Ion, and that's where you'd have a nitrogen with 4 R groups. Okay, so R4N doesn't reveal too much. It's better to write it all blown out, which is R 4 times around the nitrogen, and that would be a Quaternary Ammonium Ion. But you will see primary amines, secondary amines, tertiary amines, and you will have to know how to identify them, just like we do with primary and secondary and tertiary alcohols. So primary alkyl amines, R and H2. How are these named? Well, they're named by adding the suffix. See, I spelled suffix right this time, thankfully. They're named by adding suffix amine to the alkyl group. So these guys are named fairly straightforwardly. This is CH3, CH2, NH2, 2 carbons, right? Ethyl amine. CH3NH2 would be methylamine, by the way. So here's an example, CH3CH with a CH3 branch. We learned a long time ago this is an isopropyl group, so this would be called isopropylamine. Parentheses around it because it's a common name. The next example is cyclopentyl amine. That nitrogen is attached to only 1 carbon, so that example, cyclopentyl amine, is a primary alkyl amine, just doesn't look like it at first. All right, now secondary and tertiary amines. How do we name these guys? Well, these are named using prefixes. Okay, mono, di, tri, those are prefixes. Won't get any higher than mono, di, or tri. And we drop the mono. So example, here we have a CH3, another CH3, so it's dimethyl amine. The next example, we have 1, 2, 3 ethyl groups attached to the nitrogen. This is triethyl amine. Okay, now so far we've had the branches or the alkyl groups be identical. Okay, dimethylamine, triethylamine. But what do we do if we have different alkyl groups attached to our nitrogen? So it says, but if the substituted alkyl groups are different, what do we do? Well, let's practice by example. CH3, CH2, N, CH2, CH2, CH3. Who is the longer one? The longer one is the 3 carbons, so he gets precedence. We will call this not propanamine, that's a mistake. We will call this propylamine, okay? So it's propylamine because the 3-carbon propyl group is the longest. So then we put ethyl in front. All one word, by the way. So it's ethyl propylamine, okay? We name the ethyl first and then give propyl as part of the main root because it's longer. Better if we do another example on that since I kind of screwed that one up a little bit. Here we have CH3N, CH3, and then ethyl is the larger one, is it not? Okay, so this is going to be an ethylamine. What comes in front of that? What prefix? Dimethyl ethylamine. Why di? Because there's 2 CH3s. All right, naming aromatic amines. An aromatic group for us is just a benzene ring, right? So a benzene ring with an NH2 group, because an amine is an NH2 group. So a benzene ring with an NH2 group, which I'm going to draw, is called aniline. A-N-I-L-I-N-E. Okay, it's called aniline. I'm about to draw that. If we ever have to name NH2 as a branch for some reason, it's called amino. So this example and this box I'm putting around, this is my quote-unquote parent name for anything that's based off of a aromatic amine structure. So most aromatic amines are a derivative of aniline. For example, ortho-methyl aniline, 4-chloroaniline, etc. Here's an example. This is a methyl aniline. Okay, why is that? Well, it's got a methyl group off of the NH2. It's a disubstituted amine. Example at the bottom of the page. Are the following amines primary, secondary, or tertiary amines? CH3, CH2, CH2, NH2. Well, there's only in A, there's only one organic group. There's that propyl group sticking off of the nitrogen. This is a primary amine. For the other guy, B, I see we have 2 ethyls off of the nitrogen, so this is a secondary amine because the nitrogen's attached to 2 carbons. All right, C, I have CH3, C, CH3. So this looks very, very busy, doesn't it? Who's attached to the nitrogen, though? Only 1 carbon. So C is kind of a trick because the nitrogen is not a part of that giant cluster. He's attached to just 1 carbon, primary amine. Now the next 2, D and E, we have these kind of cyclic amines where the nitrogen is a part of it. And you've never even seen this before, but you can still tell that in D, nitrogen's attached to 2 carbons, secondary amine. In E, nitrogen's attached to 3 carbons, tertiary amine. All right. We want to name the following amines. A, CH3, CH2, CH2, NH2. This is going to be propylamine. Okay, so A is propylamine. B, I see that we have 2 methyls attached here. This would be dimethyl amine. 2 methyls attached, dimethyl amine. We have an aniline derivative, don't we? So this is going to be called 1, 2, 3, 4, 5 pentyl aniline. So the aniline becomes my root. It's a new root. We learned that on the last page. All right. Now it looks like in the next example they're going to give us the names and we got to draw the structures. Okay. Some people think this is easier. What I like to do is blow everything out and then put the structures into a nice, neat format that I can put a box around. Butylamine, 1, 2, 3, 4. 4 C's with an NH2. Clean that up. CH3, CH2, 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 NH2. Okay. B, I see the ethylamine. Let's draw that. Then I see the methyl. Let's draw that with nitrogen in the middle. CH3, CH2, NH, CH3. Okay, and I've drawn this one with some dashes in between. That's fine. All right, top of our next page here we have C. I want to draw dimethyl aniline. So aniline means I got to draw a benzene ring with an NH2, at least to start. And then I have to erase those H's and put my 2 methyls on there. See what I've done? So that's aniline, which was a benzene ring with NH2. Erase the H's because it's a dimethyl instead. D, 2-aminobutanol. So this is kind of a blast from the past. Butanol is an OH, right? All alcohol, OH. So I draw but 4 and I put my amino group. NH2 is an amino group. on carbon 2. It probably should have been named 2-amino-1-butanol, by the way. 2-amino-1-butanol would have been a better way for us to get the structure. But you see how I never put boxes around the little stick. That's just helping me get to what I eventually put in the box. All right, organic chemistry is done. Let's focus on learning chapter 11, chapter 12, chapter 14. I'll probably put together some sort of review video for organic chemistry. And that review video will be nothing more than me just kind of working on some of the select homework problems. Okay, because you've got all the content in these videos, okay? 3 videos.